Hello friends, welcome to the video lecture series on machine learning. So from this tutorial onwards, we are going to learn about one new family of algorithm, unsupervised way of learning algorithm, K-means clustering. So let's start our journey of the K-means clustering. We have already seen the K nearest neighbor classification algorithm. From this lecture onward, we are going to see another unsupervised learning algorithm, K-means. So what is Kmeans learning algorithm in a machine learning? So this is one of the very simplest unsupervised learning algorithm. It is mainly used for the very famous clustering problem available. As it is a unsupervised learning algorithm, so there is no particular training is required. You can straight away throw the data onto the K-means clustering algorithm and you will get the grouping of those data. What this K-means algorithm will do, it will group the data into number of cluster which you provide. Now what is K and what is mean is equal to? K is nothing but the number of cluster you will provide to the K-means clustering algorithm, and means nothing but it's averaging of data. So this K-means clustering algorithm works on a averaging of data and keep shifting the averaging or the mean value of the or the centroid of the data. That's how it works. Now let's define the actual problem statement of the K-means clustering algorithm. Now let us look at this very simplistic two-dimensional data hypothetically I have created. So it is a two-dimensional data, so it has an individual data has having a two feature. One is in a horizontal axis direction, one is in a vertical axis direction. I purposely created this data which forms a one cluster in this region and one cluster into this region, but at a prior knowledge we don't have any kind of knowledge that particular data set or particular data point among the all data set belongs to particular cluster or not. So for us at this moment all data point belongs to nowhere, so that's why I have given just a single color to each and every point. Now what is the actual problem statement of clustering and how we can solve it with the help of K-means clustering algorithm? So our task is to group this data set into two different cluster. Now this two, you can define any number of cluster also based on your requirement or in prior based on your problem definition. In a future lecture we'll see about what are the different heuristic to define this number of cluster, but as we have seen from the data there are mostly two clusters is possible. This part is forming one cluster where the values are somewhat lower in a horizontal axis direction also, in a vertical axis direction also, but in this cluster both the value horizontal and vertical axis values are little more higher compared to the cluster 1. So let's call it as a cluster 1 and let's call it as a cluster 2 for simplicity. So this is the problem statement. Now how we can throw this data to the K-means clustering algorithm which forms automatically grouping of this data set into one cluster and this data set into a second cluster. We can form even multiple cluster also. As this is in a two-dimensional case we can easily visualize, but as we go into higher dimension it's almost impossible to visualize. In that case you can use lot of different heuristic based on your problem definition or problem requirement also. You can define this number of cluster, but as far as the K-means clustering algorithm is concerned we have to provide this number 2 at a prior to the algorithm. Now let's see what are the steps associated with the K-means clustering algorithm. So let's see what are the first step. So first step is select K is equal to 2. In this case we have taken any two arbitrary point in a two-dimensional space as a centroid of our cluster. So I have taken arbitrary one this as a centroid and one this as a centroid, but still we haven't touched any kind of data. We have just selected arbitrary 2 point. If we have selected if we want to group the data into suppose 5 cluster, we have to select the 5 different centroid, 5 different arbitrary point, and it will be selected as a centroid of the individual cluster. Now selection of this point also has a lot of different heuristic associated with that. In a future lecture we'll see about what are the advantage and disadvantage of selecting this particular initial centroid point. In this case I have selected just randomly 2 point in a 2-dimensional space. Now let's see what further action we can take in a step 2. So now we have already got the 2 points, which is nothing but the centroid or representative of individual cluster. Now what this step 2 is telling, assign each individual point to the nearest centroid. So what will happen, that we'll keep calculating the distance of individual point with respect to the centroid arbitrary we have selected, and then we will assign individual point to particular centroid. So it may happen that half of the points or a 60% or a 30% of point will lie into cluster 1 based on the arbitrary point we have selected, and remaining all points will belongs to cluster 2. After that we'll update the centroid because we have grouped the new kind of cluster. So our green points and the red points will be updated based on the nearest point. So earlier it was here the green point and the red point is here. Now it is moving little bit closer to the particular cluster. Now this is all iterative algorithm. So let's try to iterate it one more time. So in a step 3 what we'll do, again we'll assign each point to the nearest centroid, but in this case our centroid has been updated, and again once we update this centroid point, we'll again update the individual representative of individual cluster. Now this process will keep going until we data do not change inside the cluster. So what will happen, that at the last will form will get some point which is nothing but the representative of the group of the point which are nearer in a space, and there is another point we'll get which is near into another space. So this is called as a cluster 1 and this is called as a cluster 2. Now this is, as it is an iterative algorithm, it is written that data do not change in a cluster. So till the data do not swap between the cluster 1 and cluster 2 and cluster 1, you keep running this algorithm. The moment you feel that this data is not swapping between the cluster, it is almost stabilized, you can almost finalize that this is nothing but the representative of my cluster 1, this is the one of the representative of my cluster 2. In this way we'll keep shifting the centroid and ultimately it will stabilize till the data has not been swapped between the cluster. So this green point what we get after a certain or couple of iteration or even 100 iteration or 50 iteration, this is the representative of this data set. So this all data set forms the one cluster because they are nearer in a Euclidean space with respect to each other, and this forms the another cluster 2, and this red point is nothing but the representative of these two. At the final we earlier had all the points which is a green because we didn't know that individual point is associated with any kind of class because it's a unsupervised learning, but at the final result we have got that these forms of data belongs to cluster 1, that's why I have given one color green, and that this forms of data belongs to another cluster, that's why I have given another color red. So this way the K-means learning algorithm is working, and it is dividing the whole data set into number of cluster which we have given inside. Here is a prior knowledge to the K-means learning algorithm. So that's it for this lecture, friend. In this lecture we have seen about how this K-means algorithm iteratively works. In a future lecture we'll see about how we'll implement with some random data set or some standard data set with the help of scikit-learn library. So I hope you enjoy listening this video. Please do like, comment and subscribe it.